Often confidence intervals are used to provide some quality control for manufacturing. So here we have a bunch, I gave every student a small bag of M&Ms, and it said on the package that there were 47.9 grams net weight of M&Ms. So we took the M&Ms out of the paper package and weighed them on a very sensitive balance, and we got some different weights here. So here are the weights that we got right here in our sample, and I then did a one variable stats. So let's go ahead and do a one variable stats of this. So menu 611, and I had one list. My list is called M&M weights, and I did the one variable stats and got these values. Okay, so I know what x bar is, I know what s of x is, and n is 8 in this case with a small sample. So let's go ahead and I'm going to grab a couple of these values and put them where I can find them. Okay, so those are particularly the values that I'm interested in seeing. Okay, so I'll have these where I can see them and write them down. So I have x bar equals 48.398, and I have s of x equals 0.9589. Okay, so I'll get rid of the rest of this now. Okay, n is 8. So that means my degree of freedom equals 7. So those are important numbers I need for constructing my interval. And I do want to stop and do my four-step process. So what is my goal? Well, it says, does the interval provide convincing evidence that the average weight of the package is less than advertised? So I'm actually wanting to do I'm going to want to make an estimate of the mean weight of M&Ms using my interval. So I want to estimate the mean weight of M&M bags. Okay, and this would be for the population, not for my sample, because obviously I don't need to estimate my sample. I know what my sample mean weight is. So I want to estimate the population mean weight. So now I need to check my conditions. Do I have a random sample? Well, you have no idea what I did to get this sample. I bought these 8 bags of M&Ms at a CVS, so I know I didn't really get a random sample. So random sample, no. I am hoping these bags are typical of all M&Ms. And this is something we'll talk more about later as we get into other types of inference procedures. We don't always have a random sample. Sometimes we just say, okay, it's reasonable to assume my sample is representative. I'm hoping that that is the case here. Now, you might think, well, what do we do if a condition's violated? I may have to make a little kind of in my conclusion, I might say I'm a little concerned that my conclusions might not be valid because a condition wasn't met. So that's how I'm going to deal with it. Okay, so there's my first condition. Number 2, well, certainly 8 bags is less than 10% of the bags manufactured. So that's not something I'm concerned about with my 10% condition. Now, my normal condition, I don't know that the population of M&Ms is the population of M&M weights is normally distributed. It probably is, just because that's the way machines of this type tend to work. You know, they tend to cluster around the true population mean and have a few higher and a few lower, but I don't know for sure. But so I'm going to check my sample, and certainly my sample size isn't greater than 30, so I'm going to check the graph. So I'm going to make a graph of my M&Ms. So let's do a little data and statistics page. I want to make a graph of my M&M weights. Okay, now only 8 bags. This is not necessarily looking terribly like it came from a normal model. It looks kind of a little bit skewed. I have a couple numbers that might be outliers. However, if I were to take lots and lots of bags, my guess is this would kind of fill in a little bit, that I just happen to get two kind of low bags. It's hard to say. You know, this is one that's kind of weird, hard to say. I'm going to copy this once again. Well, actually, before I think I'm not going to copy this. This is one where a normal probability plot is really useful, so I'm going to go ahead and do a normal probability plot. My normal probability plot looks like it is linear enough that I'm fairly satisfied. Not real great, but not horrible either. So once again, I'm not sure on this condition. And that's the problem with really small samples. It's hard to verify the conditions. So let me kind of make a little sketch of my normal probability plot. Okay, so there's a line, and I had kind of one here and here, and I had a couple down here, and one here, and one here. So it sort of looked like that. And so I'm going to say my normal probability plot is fairly straight, so I am okay to use a t-model. Now, just to give a little caveat here about checking conditions, conditions are kind of tricky things, and technically a lot of the things that we check are very difficult to check. So the main goal of checking conditions in an AP Stats class is not for you to be perfectly confident about all the conditions, but it is to teach you the habit of checking conditions. Because in more advanced statistics, if a condition isn't met, there are other procedures that we can do to compensate for that. Right now, we don't know those things. It's beyond the scope of this course. So if a condition isn't met, we have no choice but to kind of go ahead with what we know. But just, I want you to know that in the real world of statistics, there are ways to deal with these things. But the big idea is to check the conditions so that if there are problems, that you would know in real life to use other techniques. Okay, so we've got our goal. We've checked our conditions. We're going to say that we're going to make a t interval. So this is our work now. We're going to do a t interval for the population mean. So I'm going to make a t interval to estimate the population mean, and I'm going to do that by using x bar plus or minus my t critical value for 7 degrees of freedom, and then I'd have s of x over the square root of n. So I'm going to fill in my numbers. I haven't actually found my t critical value, so I'm going to have to do that. Let's go back to my chart. So let's see, chart 95. I'm going to do a 95%. I forget what level of confidence I wanted on my problem here. 95% confidence. Okay, so I'm going to go back to my chart, go to 95% confidence, which is this row right here, go up to 7 degrees of freedom, 2.365. Okay, so 2.365. So I will have 48.398 plus or minus 2.365 times the standard deviation, which is 0.9589 divided by the square root of 8. So there's my interval that I can compute now. So let me pause and take a minute to compute that, and then we'll also talk about ways to do this on the calculator in another way. Okay, so I typed in all the values, ready to push enter. Okay, so here's my interval. I did 43 plus or minus, that's the plus or minus here, and then here's all my information. I just realized I did that wrong. Those numbers didn't look right. I had the wrong mean. This should be 48.398. Okay, so there's my interval. Now, is there another way to get this interval a little more easily? Oh, I would hope so, yes, because this was kind of grueling to do all this. I can also go to Menu and Statistics and Confidence Intervals, number 6, and I can go to a t interval, which is number 2 here. See the t interval. And I have two different methods of input, data or stats, okay? So I could put the statistics that I already know about the data, the mean, and so let's just see what that looks like, okay? So I could type in the mean, standard deviation, and the confidence level. But, and so let me just do that. So I have the 43.398. I have the standard deviation. Let's see, what was that? That was 0.9589. 0.9589. My sample size was 8 and my confidence level is 95. So this gives me my interval. I think I typed in the wrong thing again. Dang it. Let's try this again. Statistics, confidence intervals, a t-interval, and I'm going to go to stats and OK, and I'm going to type in this time the correct number, which should have been 48. Oh, I can't even see this anymore. I gotta go back to here. 48.398. Sorry, this is taking so long. 398. My standard deviation was 0.9589. 0.9589, and my 9. And here's my sample size of 8. Okay. Okay, there's my interval. Now, this isn't quite as accurate as the other method I'm going to show you because I've already kind of rounded some of my mean and standard deviation, but this gives me my x bar, my margin of error, degree of freedom, there's my standard deviation, there's my confidence interval, the lower bound and the upper bound. The only thing it doesn't give me is the t critical value, so you can look that up on the chart, fill that in. Now let me show you another way to do this with the same menu here, statistics, and then I'm going to go to confidence intervals and the t-interval, but I'm going to enter data this time. So this, instead of asking you for the mean and the standard deviation and the sample size, they just ask you for the list that you put your data in. I put my data in the M&M weight list. I've got the confidence interval, and it calculates all this stuff for you. It gives you the mean and the standard deviation of your sample. It gives you the confidence level, the lower and upper bounds of the confidence level. It gives you the margin of error. This is definitely the way to go here. So you can get this information first and then just plug it into your formula, which is a whole lot easier. So I am going to grab this here with my little snipping tool and put it into the notes. So let's see what, I don't know if there's room for it, but we'll kind of tuck it over here. Okay, so this information, this gives you all this information that's really helpful that you can use to make your interval. And I'll move that other stuff later. Now, let's go ahead then and write our conclusion. So the conclusion then, assuming the conditions are satisfactory. Okay, because I'm not really sure that they are totally, but assuming the conditions are satisfied, I am 95% confident that the interval from, let's see, 47.59 or about 47, yeah, 0.597 to 49.200, that's good enough, grams captures the true mean weight of M&M bags. Obviously that particular size of M&M bags. Now, I was asked then to use my interval to comment, does the interval provide convincing evidence that the average weight of the bag is less than advertised? No. There is no evidence that the mean weight, and I should probably say the population mean weight, is less than 47.9 grams because that value is contained in the interval. I only have convincing evidence of something if it's not in the interval, okay? I don't know for sure that the mean weight is 47.9. It's possible that I got an interval that missed the true mean weight, because that happens sometimes, but I can't say that it isn't 47.9 because 47.9 is in my interval. Okay, so that is the conclusion then for this particular problem. What a week ending. Wasn't that fun? We got to eat M&Ms afterwards. It was a good time had by all.